Hi, everyone. I'm going to be talking to you today about view state-driven applications. As was just mentioned, I wrote a blog called Cocoa with Love. It's great. If you haven't seen it, go. You can find me on Twitter at Cocoa with Love. You know how the internet works. My goal today is just to have everyone think about view state in your applications. It's a bit confusing because we don't pay a whole lot of attention to view state. It's this thing that we might know about, but certainly in the standard Cocoa application design pattern, it's largely ignored or forgotten. And what I'm going to look at is what happens if we take this mostly forgotten aspect and take it from its position of being ignored, being just a side effect of other things, and we literally make it drive the whole application. But I'm not going to start talking about view state. I'm going to start talking about the standard Cocoa application design pattern. You've probably seen diagrams like this one here that Apple used to demonstrate ModelViewController. But that's not incredibly helpful for this. I'm instead going to focus on a slightly different pattern, which is how does a change flow through an application that follows this pattern? Ideally, what is the ModelViewController change pattern? And the idea is we have our view, and when our view does something, it talks to the controller. So maybe you've clicked on a button or you've edited text in a text field, and that action gets sent to the controller, and the controller chooses to change the model. And then the model is observed from the outside by an observer, which is probably just another controller, and the controller then chooses to update other views. Now, the important thing to note about this pattern are the two dashed lines that I've drawn there. These are runtime bindings, situations where you haven't necessarily written in code how these things are connected. Certainly, there isn't code at both ends of the connection. And you can add additional observations of what's going on at runtime. The other thing to note about this is the concept of a model context. The idea that what we try to do with our models is have them have a clean interface on the front, a narrow interface. So even though you might have lots of things that try to change the model, they all have to go in through one point. And then when the model changes, it has to come out through another point, so your observations. So there's this clean interface into and out of, and a very narrow interface into and out of the model. And things are not directly coupled. There's runtime bindings, so you can add additional observers easily to something. So if another controller wants to pay attention to a piece of state you've changed, it can just observe the same thing, and you don't need multiple controllers to actually coordinate. They coordinate by design rather than sort of hard coding everything. And that's really the reason why we focus on ModelViewController in apps. It's to get this clean change pattern through our whole app, to make testing easier because it's easy to test the model if we can separate it out from the views. Views can coordinate. Like I said, if you want to just add another observer to the same piece of state, then you can add another observer to the same piece of state. And multiple views in your app can update at the same time when the model changes. And it reduces the need for knowledge. We don't have to hard code the fact that this view over here wants to know about that model state when it changes, so whoever changes the model doesn't need to tell it directly. It'll just find out when the model changes. And because everything happens on the same path, we can do interesting things. We've got this narrow interface, and we can play with it. So I'm going to show you a little app that I've written. It's based as close as I can make it on the standard master detail template that Apple have in Xcode. So it's got master controllers, detail controllers, as you'd expect. And it's just this little app here. I might bring it a little closer into the center of the screen. Oh, no, maybe I'll leave it there. So it's an app for showing times in different time zones around the world. It's not particularly different to what you already have in the clocks app. The time app on the iPhone. But you can scroll up and down in this view. You can select one of the things. You can even change the name of the time zone if you want to give it something personal to you. So there I have try Swift down the bottom, renamed as I made it. I can also bring this up. I can add additional time zones if I want. I can say add Cairo into the list, and Cairo is now in the list up here. And I can say maybe, actually maybe I didn't want to put Brisbane in there. Let's get rid of that. And I can take it away from the list, okay? Fairly simple sort of app. Adds a little bit of data. You can go into a detail view and you can change things. Now, I'm bringing it up just to show one of the advantages you can have from having a standard change pattern going through the document, going through that narrow interface and coming back out the other side, is we can hook in things like undo and redo. So this slider down the bottom of the screen can undo the changes I've made. You can see try Swift there being renamed, and it can go back to being New York. Oops, New York is being renamed as well. Back to being New York in the list. But the other thing you can see in this is that there's a kind of inconsistency. When I renamed New York, I wasn't on this screen. So I can show you it changing here. But that's not what I was doing in the app. I was, in fact, on this screen here. So there's more that is mutable about the app than just the document. There's also the state of where I was in the app. There's the scroll position on here. There's whether or not I have this selection for time zones up or not. There's whether or not I have these things. These are not committed to the document, and yet they are mutable in the app. So simply winding the document back doesn't affect these other things. When I wind this slider back, I'm still just stuck permanently on this master view. So go back into here. So we have two separate sets of rules. We have document data that goes along this data-driven pipeline, and we have this view state. Now, the view state actually goes along what's called a presentation pipeline. The idea that instead of changing data and then responding to changes in that data, instead we bring up a presentation, like a view controller, we perform a segue, and then we try and set the data after the fact. So instead of the first pattern that I showed you, the one up the top, we have this shortened pattern which just goes view to controller, segues to another controller, which brings up a view, and it may or may not actually bring up any data. Many times it doesn't. You know, when I bring up the selection controller, it doesn't actually contact the model for any data. So we have these truncated patterns. And it's a little bit more than even this document will show you. It's a little bit more than you can even easily see in this diagram, because the top one has the model context. It has this consistent interface that's going into and coming out of, whereas the one on the bottom doesn't. There's no consistency about it. Every controller is separate. Every controller is hard-coded. Every controller is running on its own different sets of rules. Now, I just want to show you in code the difference between these two ideas. And let's have a look at a data-driven path. The data-driven path is there at the top. If we delete a row in a table, that's a data-driven path. The first thing we do is that top green line you can see, which is we remove the object from the store. And then at a later point, we handle a change notification from the store. We resort the objects, and we reload the data in the table. So that's a data-driven change. A presentation-driven change is like when we select a different item for the detail view. So we click on a row in that master view, and it brings up the detail view. The first thing we do in that is not to change the data, but to change the presentation. We say perform segue. And then at a later point in prepare for segue, then we finally set the data on the controller. So you can see the very last line there, controller.timezone equals timezone. It finally sets the actual data for the view. So in a presentation-driven, we have perform segue first, and at a later point, we're doing setting the actual data. Now, while I'm still on this screen, I want to point out a line to you, the ugliest line there on the slide, which is let controller equals segue.destination as UI navigation controller.topViewController as detail view controller. This comes straight out of the template. The idea is that if you need to change the detail view in a master view controller, the master view controller, despite its name, it isn't actually at the top of the view hierarchy. It's actually a junior view of the split view. But it needs to know about the whole hierarchy. It needs to know about the split view. It needs to know that the detail view has a navigation controller displayed in it. And it needs to know that the top one is going to be a detail view, and it wants the time zone. Because we don't have anything that's actually coordinating all of the patterns across the app, because we're not observing a common point, when we have a presentation-driven approach, we have to hard-code knowledge about the whole app into everywhere where a change occurs. So the consequences of this presentation-driven approach that affects all of our view state across the app is that we have total coupling between cause and effect. The master view controller needs to know everything about the detail controller. It becomes difficult to add dependencies because the detail controller wants to know what's selected in the master view. Every time anything else wants to know what's selected in the master view, it's also going to need to have all of this crap added to it. Controllers are intercommunicating in order to send segue data, and it's just a bit crazy. And there's no clean interface or other testing hooks because everything's sort of hard-coded. Nothing is going through a common place. So we have this situation where we have data-driven approach for our model data, for our document, but we're failing to apply the same lessons that we've learned over the years. Model view controller, separated presentation, keep these things apart. We're failing to apply the same lessons to our view state. I mean, they're both critical to our apps. In a small app like this, there's in fact more view state than there is actual document. And we want them all to be tested, and they all have to be persisted in a well-behaved iOS app. We should be using UI state restoration and other things in order to preserve all of them. But it's difficult if we're not even paying attention. So what I'm going to say to you today is that everything mutable in your app is actually a model, whether or not you're representing it as such. View state is a model, and changes to view state should, ideally, be taking a data-driven path. We want all of these things to have the same advantages. So I'm going to start by looking at the actual document, the normal document of the app. So this is the model that's used in the app. It's an app that just presents time zones. So most of the document is just that dictionary of time zones. The dictionary is just between the UUID, which is nothing but a key for the row, and these time zone structs. And the time zone structs have a name that you can change. You saw me edit the names of different things. And it's just an identifier, which is the time zone, and the UUID, which is nothing other than a row ID. The important consideration, and what I'm talking about here, is that what you need to know is what is mutable in the app. So we have the mutable time zones, and we have the mutable name. Let's go back to the app and think about what's actually mutable in the views. So the views have a scroll position on this master view. We have whether or not I've selected a detail item. We have whether or not we're in editing mode. We have whether or not the select time zone screen has come up. We have a scroll position in this one as well. And we have a text field here. Notice I didn't talk about the text field in the detail view, because that's immediately persisted in the document. This is a text field that doesn't go via the document, so it's truly view state. And if I'd actually written something that's a city, you can see things come up. So what we want to do is make all of these mutable things into their own model. Now I have a different branch. Let's check it out. And I'm going to build that while I switch back to here. So these are the mutable aspects of the app's view state. It has this split view state, which always has a master view. It might have a detail view, and it might have a selection view. Now, the master view has its scroll position, and it has whether or not it's editing. The detail view actually doesn't have any mutable elements. The only interesting part of it is whether or not it exists at all. And then it just has the UUID as its sort of identifier. And then the selection view state, the thing that lets you select a new time zone, It has a scroll position as well, and like I said, it had that search text field up the top. Now, what I want you to think about is another advantage of having models, which is that they are abstract representations of the app. The actual model, that I showed you, the document, just had the time zones and a name and a UUID and an identifier. It was about 10 lines. And here I have another 30 lines. And between the two of them, they represent the whole 600-line app. You can point to these and say, this is the whole app. It's interpreting these things in different ways for presentation. But these show all of the states that we can get our app into. And these are the things that we're really thinking about when we're writing the app. So having this kind of model is a great way of thinking about your app. When you ignore all of these things, you might not have a good idea in your mind of what you're really doing. Now, how do we apply this kind of model? So previously, when we wanted to bring up the detail view, that top one is just what I've already shown you before. It does the perform segue, the green line at the top there, and it sets the controller's time zone immediately after that ugly digging into the detail view controller. To do it in a data-driven approach, instead of performing segue as the first action, we set the detail selection. So it's the first green line under the view state driven, data-driven heading there. The first green line is view state.shared.set detail selection. So it sets the detail selection on the view state model. And then all we do is, in the same way that we prepare for segue, instead we now handle that view state change. And the last thing we do is perform the segue. We're now changing the data first, and then the whole view state of the application responds to that. So we've gone from presentation and then data to data and then presentation. We've literally turned the whole app upside down, and the insignificant part, the view state, is now the most significant part, and the presentation is now less significant. It's just a response to the view state changing. So let's have a quick look at how that changes the app. So I switched to the master branch from the undo redo branch. OK, so the app looks pretty much the same. I can still go into try Swift and say, you know what, I'm going to go back to it being New York. I can bring up the editing thing. I can say, bye-bye Perth. I can go into here and say, actually, no, I've forgiven you. Let's have you back. And all of the other features that we previously had in the app. But now, because view state is a model, and the model is a model, which I sometimes call the document model just to distinguish it, we can wind them all back at the same time. Instead of just undo and redo on the model, we now go all the way through the entire state of the app as quickly as that. So you can see me changing try Swift here. You can see me bringing up the whole thing. Everything that I went through is now as simple as that. But there's another point, which is they are models, both the view state model and the document model, but they're not the same model, and we don't have to wind them back at the same time. So here's me winding the view state back without the model. Here's me winding the model back without the view state, although you can't see anything happening there. We have this ability now to control view state and model independently, so we can test scenarios that might have been difficult to get into otherwise. Let's go back to here. So the ability to wind back view state is sometimes called time travel in different design patterns. It's very common to see time travel happening in unidirectional data flow, which is a way of putting your entire app on this tight little loop, used by libraries like ReSwift. But you don't actually have to completely redesign the architecture of your whole app to do things like this. A view state approach is really just thinking about your view state as a model and putting it on a model pipeline. The clock sample app that I showed you is really very, very close to Apple's master detail app template. All I've done is added a view state model that isn't in the standard template and just made sure that the same changes that I'm doing on the same path that I'm doing for the model data is the same path taken when I update view state. So like I showed you when I was sliding back the view state without the model, is it gives us the ability to test things. You know, on its own, time travel isn't useful. You're not going to deploy it to your users. But testing of user interfaces is notoriously difficult because it's very hard to decouple the entire Cocoa framework from the little aspect that you're trying to test. Meanwhile, the models are very easy to test. They're not connected to the whole thing. We can observe the model and make sure that as we're making changes, the correct notifications are sent out, the correct state changes occur. And I don't even necessarily mean unit testing is helpful. I mean, what if you're just playing with your app and something quirky happens? If you're logging the view state as you go along, then you've got little sections in your log, like you can see up here, this little section of JSON. You can say, oh, my app was in this state when it did that thing weird. And you can see two states change in your app, and you can say, oh, my app went from here to here, and oh, gosh, I don't handle this correctly when I make that transition. You want to know how to, if you want to fix that problem then, all you need to do is copy that JSON out of your log and play it back in the app later, and you can make your app go from states that might be difficult to transition between ordinarily. So for example, in the Clocks app, there's a selection view that comes up, and that animates back down, and then there's also a detail view, and that comes in from another animation. It's almost impossible as a user to select one of the rows in the master view and have the detail view transition in while the selection view is still transitioning out. Almost, but not totally. If you wanted to actually test that yourself, you'd have to be crazy fast with it. And it's almost impossible to get Apple's UI testing approach to handle it either, because it's a bit sluggish at times. Yet, if you're just driving the whole interface with these little set JSON on the view state, set JSON on the view state, you can just go there instantly. There's no difficulty about it. You can perfectly replicate these problems every time. And the end result is that we end up with our view state data going on the same pipeline as the model data. Now, there are some drawbacks to this approach. The biggest one is that if you remember, the shortened presentation-driven pipeline that I drew just went view, controller, controller, view. It was this tiny little thing. That actually does mean it's less code. But it's code that you write every single time. And so it's difficult to test code. It's nebulous. It's through your app. Putting things through the model, having a whole model interface set up and making sure you're handling notifications coming out of the model feels like a little bit more code to start with. But it's code you're already doing for your model data. It's not something you're unfamiliar with. It's just a little bit more of the same. And you get all of the benefits that you have. You know, the very reason why you don't take shortcuts with your model is the very same advantages you get by not taking shortcuts with your views. So what I came here to talk to you today was to think about view state. Just pay attention to the fact that there's all of these little bits of state everywhere in your app that you might not be capturing, that you might not be paying attention to. Because in reality, everything mutable in your app is part of a model. Whether or not you're representing it as a model, it is a model. There is a state in your app, and here's the state. Standard Cocoa apps treat this entire model as just a side effect of presentation. I've brought up a view controller, that's the state. But if we turn it around and we think about view state as being more important, then presentation is a consequence of the view state. And we can really gain a lot by sort of thinking about it the other way around and making this sort of side effect the most important part of the application. That's going to be the whole thing. the project is available from my GitHub, mattgallagher.com/clocks, and you can find more on my website. All right, thank you very much.